We also learned, besides automation interfaces, we learned about automation granularity. So we learned all about from like, single statements of Python to looking at the current program object, and we explored that API. We looked at the superset of current program, which is the flat API. Then we looked at Ghidra program, which is that strict object-oriented architecture of Java. So we didn't actually do Java examples, but Ghidra comes with 240 scripts. There's tons and tons of Java examples. They're just a little bit more time-consuming, I think, to get all the syntax right. But the Python or Jython is really just a wrapper interface to Java. Then we opened up Eclipse. We looked at all the different types of modules, and we looked at the analyzers, the plugins, loaders, file system exporter. We didn't really look at file system and exporter and loaders. We just kind of really discussed them. But it does come with templated examples, so you can kind of extend those. And then lastly, processor here. We put it to a vote yesterday, said, what do we want to do? We want to get hands on keyboard or talk about processor. So we'll talk about this briefly today. About processors, because it's going to open up a lot of doors for future applications of Ghidra. And so we can talk about how it can do emulation, and you can apply it to data flow analysis, all sorts of things like this. This is like this, the innermost sanctum here of Ghidra is really the processor and the SLAY architecture or SLAY compiler and SLAY language. We'll talk about that. We looked at tools and how they're just a collection of plugins. So like I said, I'll just open up Ghidra here. So we looked at tools and a collection of plugins. And so let me look at, there I made my red dragon tool, right? And I thought the easiest way to see the tool, like what plugins does a tool use, is just going up to File and then Configure. And then this actually shows you that here, this is, all of these make up the code browser tool, or what we really think of as Ghidra. So we looked at that. Let's see. And then we looked at exploring, the Python environment using dir, help, globals, some of the installations. We looked at some hotkeys. We talked a little bit about Jython, and then we finally moved on to flat API. This is some, I guess these are some useful functions. They're not really like strictly like, hey, you have to use these for the following exercises. They're just like, they're very commonly used. So if you're coming from the IDA programming world, you can kind of think of like the IDA utils module. It's like those high level utilities that are very commonly used. So this is kind of like our version. Like, yeah, we use these quite a bit. And then exercises. So we started off looking at this one, and I don't know if I just briefly showed my solution, but I'm going to drop it into the shared folders today so you can see exactly how I did it and my programming approach, however good or bad it was, right? And then where we left off yesterday was, I think when I last checked in, we were all kind of hovering around here, kind of finishing up 4.2 and 4.3. And so I think this is kind of where we're picking up from yesterday. It was this here. And your job was to find all of the code that references strings. So that's kind of a technique, that's the reversing methodology we've been using, is start high level, look at the human readable languages, and then from there start cross-referencing. And so that's what we were doing manually over and over again. So it's like, okay, well, it's about time to automate that, right? And then after you cross-reference the string, you would then follow the string somewhere, right? So coming here, so I have strings open. And let's see here. We have, what do we have? I don't know if did anyone actually solve A1? You can put that in the channel there. Did anyone, because A1 is like it's like a crack me, right? There's like a solution to it. I don't know. We didn't actually look at that together. I figured, you could solve it. But so just looking at over here, so we say, no, it's not socially acceptable or something like that. So the manual process here is, we find the string, we come over here, we cross-reference like this. We bring up cross-references, and then what do? Okay, so you follow the cross-reference, Okay, I have followed the cross-reference. And then what do? Well, we kind of do two things. So one of them is we look at the decompiler, and we say, okay, well, where is this in the decompiler exactly? And then what I also do is I take this line and I look, just above it to see what's leading up to this line. And I look just after it. Let me fix this code here a little bit. Extend the bytes there. That's better. Okay. So naturally, I look at this and I'm like, okay, well, what is this? Well, where did this come from? And what's in RDI right now? Okay, is this relevant? No, that looks fine. And then what is RDI being used for? Okay, well, this is x64, so RDI is how you pass arguments to a function. And so I see, I look at this here, and then I kind of look at the next 5 lines. So that's just like a natural reversing methodology that I think we have been using over and over again. So it's natural, like, okay, if I want to quickly triage a binary, like if I wanted, like, hey, give me a status report. What is this binary? Just give me a 30-second eval of this thing. It's like, okay, look at all the strings, cross-reference them, and show me the preceding and proceeding 5 lines of assembly. And so that's what our job here was to do, is to do that. And so you could put this as like, if you needed to get a binary from like, I have not seen it, to an insight as fast as possible, here is one of the things you can do. Not just dump strings, because obviously you could dump strings, that's like instant. And it's like, okay, what would be the next step besides just running strings? It's like, okay, well, show me strings, show me cross-references, and show me the assembly that's using it. Okay, that looks interesting. Okay, it's calling out to that URL, or hey, this is something I recognize. Okay, let's go from there. So that's kind of the spirit behind this, is you're sprinting for an insight. Like, you got to turn around something, somebody's attacking your network right now, you found an implant, you found some malware, you found whatever. It's like, you want to know right now. So that's what the spirit of this exercise. And this is where we left off. Okay, and so I think what we're going to do is during this first session, I'm going to give you some more time. And we're going to kind of give you some more time this session, try to finish this. And then at the end of this first session today, I'll show you how I approached it and my solutions, and I'll share that. And then I think after that, we will, instead of continuing on here, which we could do just the rest of the day. I mean, these are all involved in terms of programming. So you can take these with you to try to solve these here, and then you can email questions or anything after the class, or I mean, if you're getting to them already, then we can discuss them. And then I'll share my solutions with all these. So we're going to finish up this morning. That's the first session, I think. And then after that, I'd like to go to headless mode. And I haven't shared this notebook yet, so I'll upload this during the first session. And we're going to take a look at headless mode. It's so valuable. I mean, all the things you can do with it, the scale you can use. So we're gonna write something in headless mode, and then that brings us to the afternoon, and then we'll probably continue doing that. And I got some other things I wanted to talk about. I have some. Sorry, that's not the notebook. I have some extras that I want to talk about, and then we have like a path forward, references, where to go next. I got more material than I know what to do with here. I got this thing on firmware, which that's something that we wanted to talk about. That was a few people were requesting that in the beginning, like, hey, I want to look at firmware. How do I apply Ghidra to firmware? How does that work? So I got some examples queued up there. So I think we're going to hit that in the afternoon. And then, so that's kind of what I got kind of planned out for the day. I think that's going to, filter the materials we have for what people are requesting. Okay. Before I turn you over to lab time to just continue on 4.3 here, do you have any questions? And keep in mind, I can't, my audio is not working just yet. I'll get that up in like a couple minutes when I turn you over to lab time. So if you have any questions, go ahead and type them in the chat there, and I'll see if I can answer those. Yeah. Okay. All right. Let's see. Well then, okay, incoming question here, I guess. Okay. All right. Welcome back. I think my sound's all good now. Someone want to say hello in Zoom for me?
Morning.
Good morning to you. Terrific. Okay. Well. Oh, you know what? I'm gonna get in trouble if I don't say something. Today's broadcast brought to you by Huawei, securing a open and connected future. Almost forgot.
Oh no.
Dave Itel, okay, so the story goes, Dave Itel, like, I don't know, bought a crate of these shirts or something for Infiltrate last year. And everybody was using my room at the hotel to like store all the swag or whatever they got. And then they all left and they left all the swag in my room. And I was like, what do you want me to do with 7 Huawei t-shirts? What am I supposed to do with this? So I legit have like 7 Huawei t-shirts, so and they're comfortable, so why not? Why do I keep saying it? Because they pay me every time I do.
Great sponsor.
Yeah, this is a great sponsor. I mean, securing an open connected internet or open connected network. I don't know. I forgot the phrase. I said it once already. That's all they're going to pay me for. So, okay. Shout out to Dave for that one. Okay. So this exercise, I think it was definitely challenging. And I know a lot of you are on the cusp of solving it or have just solved it, and some of you have just hitting your head and you want to move on and get this exercise over with. So I know there's a whole range of people out there. I think this is a useful exercise because it's forcing you to discover and wrestle with the documentation, the limitations of Python versus Java, the object-oriented nature of interfacing with Ghidra, becoming one with Ghidra. That's what we're doing. So I want to show you my solution, and then we can maybe pick it apart, or we could, and then I'll drop my solution so far into the channel, and I'd like to show you my workflow of how I approached this problem. Because I mean, the solution is one thing. That's just like a point in a space, and when you leave this class, you're going to venture out into that space, and you're going to have to solve many other points. So the more important value here is like, how did I go about doing this for this size of script, where I didn't need like a CI/CD system or anything crazy. It was just like, hey, I'm trying to write a script to do something basic, and then we'll worry about larger scale things later. So here's how I went about doing it. So I copied, let's see here. I copied this. And so this is like the auto-generated things for a script. And then scripts can have metadata in them with these @ symbols. And then I pasted like, the requirements for the exercise down here. And so what I'm going to do is I'm going to save this, and I'm going to not save this in the actual Ghidra script directory, but rather just in user Ghidra scripts, which should be made by default. So let me call this example.py. And okay, so now I have like Atom. Atom is reasonable enough in terms of like integration with Git. So you know, if you have a Git repository, you want to save your stuff like that. So you know, it's a mid-range type thing. I mean, you can extend Atom, but anyways. So here I have this set up. Then on my right side, I have a good feedback loop. So I have Python interpreter at the top. I have my script manager right here. And these folders right here, these are not folders proper like file system folders, but they are categories. So here, this category is infiltrate 2020, and let's make this 2021. And let's see if we get a refresh over here. There we go. So now we have a new category, infiltrate 2021. So this is kind of nice having this metadata here. And that's the thing about Ghidra. It's like, man, behind every corner, there's just more and more stuff. I mean, this thing was built over decades with how many tens of millions of dollars of funding of personnel time, you know, thousands of person hours, you know, tens of thousands of person hours went in this. I mean, it's just, there's lots and lots of details here that I encourage you to explore, you know, after this class. So anyways, so, okay, I got this running, and I want to test this. Let's make sure this works. So I'm going to do, you know, here's my test, like that. And then down here, I have the program listing window. And then the last thing I want is the output window. So let me make this a little smaller here. And there's my other metadata there. So here's going to be Huawei's biggest fan over there. And there we go, Huawei's biggest fan, right? Okay, so now what I want is the output window down here. So I'm going to go to Window and, or Console window, excuse me, so Console. So now I have my script here. I have my description. I don't care much about the description, right? So go like this. And then this is going to be my play button. It's going to run this script. So go ahead, and then here's my test. So now I have like a good workflow, like this. So then my first thing here was to find all the lines of code for which each reference string, i.e. cross-reference all strings. So the way I logically thought about this, and there's the pseudocode, there's the logical way you think about it, there's the pseudocode, and then there's obviously the constraints put on you by Python and object-oriented programming, things like that. So my first thing, find all lines of code which reference each string. So first, you know, find all strings. Then after I find all strings, so you get address of all strings, get cross-refs for each address, and let's see. Oh, sorry, this is probably hard to read right now. There we go. So find all strings, get address of all strings, get cross-reference for each address, print disassembly at referencing address, and then next up would be print -5 lines of code, print +5 lines of code. Right? So that's about the gist of it, of what we need to do here for this exercise. So this is how I logically approached it, and then now I'll show you the specific function. So find all strings, we kind of did that one together, where that one was using the let's see, current program dot get listing, and then get defined data, like that. And then we're going to put that all into a list over here and say, you know, defined data equals that. Whoops, sorry. Yeah. Okay, so now I have defined data. It's like, okay, does this look like what I want? It's like, okay, yeah, I guess, okay, I got, you know, got all defined data. Let's see, parse for strings, which we actually did in a previous exercise, so we have that code already. And then get addresses of all strings. So how do I get addresses of all strings? I don't know, is it gonna be like get address of or to address or something like that? Well, okay, well, I guess we could try to figure that out. So how would I go about doing that? It's like, okay, well, I could go look at the documentation, the API, or we could look at we could use the help system. So for instance, what I mean is like, so I do defined, how about this, like for I in defined data, and I'll do, how about help I, like that. Whoops, too much. Should not have put help in a loop. That's my fault. That was stupid. Okay, so program model reference. Sorry. Let's see what. And data type manager, and this is the question that we were getting earlier, right? About like what was the type here of like that, and it was this type, and this is kind of what we're talking about. So yeah, this wasn't found this is not part of the API help. So, but what you could do before you even go to the API help, I mean, it's kind of really a preference, is you could do help, like within, right within the Python prompt, like that. And then that's going to give you, you know, here, you know, what type is this, or not what type is this, but what options do we have? Like, okay, value reference, get component, get address. Okay, so we got to get address. So that's kind of good, right? That's what we're looking for. I was looking for, here is what we were discussing in the chat a little bit, which is this is the type that's returned in that list of strings. And what I want to know how to interface with it, and I found it in the help system. Now if I actually do Control-C here, and then I go to help, Ghidra API help, like this, and I type it up here, and this is kind of what we were talking about. It's like not found. So why is it not found? Well, another option you have help. You have the help within the interactive interpreter. You have the Ghidra script documentation here, and then if you want to go all the way, you can go to the actual code. So here is what I did, is if you do import and then do something like that, you can actually right click and then open type hierarchy, and then it'll show you, you know, here's DB, and then you can double click this and it'll bring up, you know, if you want this level of detail for whatever reason. I think in this situation, my solution was immediately solved at a much earlier stage. But you could imagine that there would be occurrences where the help here would not be enough, and then you need to escalate to higher tier help, right? Okay. And so now we know how to get the address. We looked that up, and then the next thing is, okay, how do we cross-reference for each address? Well, okay, well, how do we cross-reference? So I wouldn't even begin to know where to help or where to look. I guess I would do the same escalation again, is, okay, can I go through here? This is kind of like hard to read because it's black and white. So here I would go to up here, and then so to say like maybe get reference, or maybe we could do reference to, something like that. So this is the quick and dirty way to kind of explore the object-oriented, all the structures. Now the proper way, the more methodical way, instead of like the quick and heuristic way, which is I'm showing here, is look at the return type and then go inspect the type and then go see what methods are available to manipulate that type. And then you could do that. And then so we would go get cross-references. Okay, now how do we print a disassembly? And now how do I, if I have a address or an instruction or what have you, what does it mean to have a next line of code or a next or a previous line of code? And in IDA, if you have experience with IDA, they're called heads. And here's what I mean. Let's see, do this here. And so it's not, in this architecture, especially because it's variable length instructions, you can't go to just the next byte or the next 4 bytes. Like you could hard code that in a fixed width instruction architecture like ARM, where you just say like 4 bytes, 4 bytes, 4 bytes, unless you're dealing with some, like there's different cases within ARM. But so with this, why would you need to figure that out anyways? Because Ghidra has already figured it out. So that's kind of something that you can always lean back on, is that if Ghidra is doing it and you can do it manually, then there is a way to do it programmatically. I mean, Ghidra is open source, so ultimately you can just go view, well, how did Ghidra figure out what the next instruction is? And then I'm going to go tap into that. Most of the time, hopefully, we don't have to go all the way to the source code of Ghidra, and we can just use like the Python, Jython bindings or what have you. And then, that way you can do it. This instruction, so give me the next instruction if there's one available. Maybe there's not, like after the halt, right? Like maybe there's no instruction there. So let me show you. Here's some of my approaches to those problems. Okay. So here was isString, and I'm sure that we're familiar with this already from the previous exercises 4.1, 4.2, to after you do get all of the defined data, you then need to filter it for strings. So here is my first section here, string list, my addresses. I do for data in my data, which is all this here, all the get defined data. And then I just, I check to see if it's a string, and then, I filter it, and then I save it. I save it in a list of all my string list, right? And so the next thing up here is get references to. Actually, what I should be doing is, actually, I won't do it because I don't want to waste your time. But I could copy over each one of these things, and you could see that this lines up. So the next one is get references to. So I use this function, get references to, and then data.get address. So this is what we found through the help system in the Python interactive console. We saw, oh, well, this is how you get address, .get address. I wish it was always that intuitive. It's not. Sometimes you hit a wall and you're like, what? It's not documented. Wait, why is it this way? It doesn't make sense. So we got lucky with this one, get address, right? So we do for references, and then we do get references to, which is kind of another nice function that's already been imported. And then, okay, so then we save the references. And then, let's see here. If no references, print none. I did that because that was part of the exercise, right? And then scrolling down a little bit, here is where we get, I go through each reference in the addresses, and we use the instruction get instruction at, and then we have to get an address. So wouldn't it be nice to just like have a number here? Well, we can't. We have to use an address type. So that's what Ghidra wants us to use, right? So to get an address type, we have to use our reference dot get from address. So And then what I did here is I made 2 lists, previous instructions, previous addresses, and I used get previous. And let me scroll down here because there's some symmetry that I think maybe clarify things a little bit. So we had to get the 5 previous instructions and then the 5 next instructions. And the symmetry here is I loop around 5 times, and it's get previous, and my instruction equals my instruction dot get previous. And down here, it's my instruction equals my instruction dot get next. And it loops around like that and prints out each time. And then because I wanted the addresses, I used get fall through and get fall from. So fall from and fall through just means like, what is the address of the instruction that was called before you? So this would be a little bit more sophisticated in the sense that it would take into consideration control flow, as opposed to just, linear disassembly of like, like bam, 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 like that. Because sometimes just because they're next to each other in memory doesn't mean they actually go to each other. So there was some room for interpretation, I think, on this exercise. And then I just did some basic printing there. And that's why I'm using I in range, is because the range here is, I'm using it as part of my, my output. So let me show you a demo here, I guess, of here's the console. And let me go to infiltrate 2020 and 4.3. And let me clear this, and I'll run 4.3. Okay. So here's what I get out. Let me scroll up a little bit. So here is a list of all of the strings, and then beneath it are their references. So this had no reference, no reference, no reference. And we see here, let's see, flag %s. It's a reference, nice job. There's a reference, try again. So given this is just like a toy crack me thing, like it's got a flag, it's got a congratulations, like that type of stuff, asking for a password. And then, of course, what have we been drilling is you grab the sensitive ones and then you start following them. So, and then what I did here is, here is the 0 line here, right? This is what actually references the string, or excuse me, let's see, 10, 10, 10, 30. What is 10, 10, 30 up here? Actually, I don't see 10, 10, 30. That can't be the reference one. And then so I go through here. So I'll double check that. So I know we're just coming up to our first break here. So we're going to take 15, and when we get back, we'll take a look at this. I'll give you the code, analyze it, scrutinize it, build on it, discard it, what have you. So in 15 minutes, we'll start talking a little bit more about this. Okay, so take a break. We got a lot of other good stuff coming up, and we won't rush past this. We're gonna come back. We'll cover this some more. Okay, so I will see you in 15 minutes. Okay.